right? So paper 6 is alternative to practical, and it's for 40 marks. So it's one of those, it's part of the accumulative or the cumulative score. So the same efforts that you placed into paper 4 should be put into paper 6, because it all accumulates to get you an A star or whatever good grades you have. And so this class is going to be really not too lengthy because I have other classes. So I'll just summarize and then we'll solve some past questions, majorly February, March 2024. So we'll solve some of those questions, and I'll give you some tips that could help you, right, in the study. Now, paper 6 is quite easy once you know what you're doing, right? You don't have to cram or memorize a lot of things because most of the information will be given in the paper. So what you just need to know is to understand how titration works, how rate of reaction works, right, and how certain apparatus are used. All right, so I'll just share my screen now and give a summary of some of the things you need to know before going into examination. So this is more like tips that should help you to do well. Okay, so let me share. Okay, so I just want to share some tips that you need to know. Okay, so one of the first things you need to know as you prepare for the exams is, okay, I'm going to start with the tips for paper 6. So tips for paper 6. All right, so basically, you need to understand, number one, the laboratory apparatus, the various laboratory apparatus, and their uses. Okay, so you need to know why certain apparatus are used for certain reasons at certain points of an experiment. And of course, you could see more of that information in the textbook. Okay, you get some of it in the textbook where you talk about the burette. What makes the burette a suitable apparatus is that it has a variable volume. So the burette has this function of measuring variable volumes, right? While the pipette kinds of measures exact volume. Okay, so this measures exact volume. All right, so usually you're expected to look at each of the apparatus and their uses. Okay, ensure that you are not using the wrong apparatus for certain functions. Okay,
sorry,
you're not
sir.
using. Yeah.
Please, can you minimize? Just supposed to maximize. Yeah, thank you.
Okay. All right. So I think it's better this way.
Yes, sir.
All right. So these are tips, like I said. So the burette can measure variable volumes. The pipette measures exact volume. And most times we use acid. We use the burette to measure the acid, and then we use this to measure the alkali. That's when you're doing a titration experiment. All right, so that's one of the first tips you need to know. Look at every of the laboratory apparatus. I think if you check your textbook, you can see a lot of them here. So each of these apparatus, you have to know what they are used for. All right, and you'll be good to go. Okay, so that is one thing. Most times people make the mistake of saying that the spatula is used for stirring. No, you don't use the spatula to stir. We use the spatula to transfer, solids. Probably you want to weigh some solids or a salt. You could use the spatula to, transfer some of the quantity into where you want to weigh it. All right. So we also have the clamp and stand. We already talked about the burette. When you're having a reaction where you have to condense or probably distillation, that is when you apply, you use this condenser. You are preparing a salt, okay, and you want to evaporate it, you could use the evaporating dish. All right, we also have the boiling tube. We have the Bunsen burner that supports used to heat. Okay, but you could use a water bath for a better controlled temperature. So an upgraded version of the Bunsen burner is by using the water bath, the thermostat, or the thermostatic water bath. This will enable you to regulate temperature. And of course, when you're talking about filtration, you know that you need a filter funnel, you need a filter paper, okay, so, and you also need a vessel or kind of a container to collect. Then you know what the stop clock is used for, to measure time. Then for the syringe, we're trying to observe a reaction where gas is produced. So the syringe is used to measure the volume of gas. So instead of using a gas syringe, you could also use an inverted measuring cylinder to measure the volume of gas. So that is just it. Mortar and pestle for crushing, okay? You want to convert the lumps to powder, you need a mortar and a pestle. The thermometer for measuring temperature. We've talked about the volumetric pipette, which is to measure accurate volume. You can only measure one exact volume. That's one thing about the pipette. Just one volume can be measured. Okay, so, and it's accurate. Then we have the gauze, which is used to support the tripod right here when you're heating, to ensure that the conical flask or the beaker is not directly affected by the heat. So that's just a summary of what you need to know about this. So it's important. So if you have not done that, go and look at each of the laboratory apparatus and what they are used for. All right, so that's the first tip I'm giving to those in the class. Okay, so I'm going to go to the second tip, okay, to help you. So I'm going to title it tip number 2. Tip number 2 is to look at the various variables. So the various variables and how to make use of them. Okay, remember we talked about 3 kinds of variables. We have the control variables, right? The dependent variable, right? And the independent variable. So especially the last question on where you're asked to plan an experiment. You have to know some of the variables you have to make constant, or I'll call it constant variables. You have to know the variables you are going to keep constant. You have to know the variable you are going to measure, and you have to know the variable that will be changing. So information like that is seen as well in your textbook. You can see the meaning of each of the variables. Okay, so you can see here, it says the control variable is a variable that that is kept the same during an investigation. So if you're asked to investigate a reaction, probably the rate of reaction, and you're asked to keep, you could say you want to keep the temperature constant. So keeping the temperature constant means your control variable is temperature. And then we also have the independent variable. This variable is a variable that is altered during the scientific investigation. So this is what you kind of alter to compare the 2 experiments, okay? You want to compare 2 entities. So this is one you have to alter. So you have to know your variables. And then there is a dependent variable this is one you measure, okay? So for instance, you're trying to determine the rate of reaction. You're measuring the volume of gas produced. So the volume of gas produced is the dependent variable. And what you probably change the mass of the metal or the amount of the metal. That could become the independent variable. But what you measure after you have activated the independent variable is the dependent variable. So you have to know that, okay, and you know that for you to have an accurate experiment, you need to have repeated it and be sure that the results align with each of the experiment that has been done. So repetition of experiments is one way to ascertain that the experiment that you have done is actually correct. All right, so that's the second thing you need to know. And then another thing you need to know is you have to understand the principle of paper chromatography. Okay, paper chromatography is one area that you might likely have a question from. Okay, so paper chromatography, remember that you have a solvent, all right, and you know why you have to use the solvent. The solvent needs to be one that can dissolve the substances you're trying to separate. Okay, and then you could have a diagram of the chromatography paper, and then there is a line that is always drawn, right, to where all the substances you want to separate are spotted on the line. And remember that the line is drawn with a pencil, because pencils do not affect, or pencils are not simply soluble in the solvent. Okay, this pencil doesn't affect the reading. So the solvent, um, kind of, like we said earlier, the solvent must be something that can dissolve the solute, because as the solvent properly dissolves the solute, it makes it easier for the solute to travel all the way up the paper. So you have to understand the principle of paper chromatography. And when you're dipping the paper into the solvent, you have to ensure that the level of where the solvent gets to is not too close to the line. Okay, so you have to give an opportunity for the solvent to rise a bit and separate. So this is okay. So your solvent level, so when you're dipping it into a solvent, don't dip it completely in the solvent such that the spots that you're trying to separate would also be in the solvent. No. You ensure that the spots are not into the solvent completely, but you give enough space so that the solvent will rise gradually up through the paper to where the solvent is, where the substances are, so that separation can occur. So you have to understand the basic principles. I think in one of the 2023 papers that I did a video on YouTube on, I talked about this more. Okay, so you could go back and watch that video on the principles of chromatography, paper chromatography, basically. And of course, the RF value, the calculation for the RF value, which is distance traveled by substance divided by the distance traveled by the solvent. So distance traveled by the substance divided by distance traveled by the solvent. So just understand the concept of paper chromatography. And remember that when you have trying to separate and you just have a single spot, okay, that should tell you that the substance is likely pure, as if you know that the solvent should have dissolved that substance. So it tells you that that substance is likely pure. And if there are several dots, several separations, that should equally tell you that the substance is impure and it's a mixture. So it involves several components, okay? So that is that. So go and understand the concept of paper chromatography. And just like if you have any question, you could just type it on the chat box, sorry, and I'll respond to them. Right. So I just want to give us tips first before I go to the paper that I intend to solve. And then tip number four is that when you are reporting your data, so when you're reporting the data, ensure that the values are in a one decimal place. This is very important. So the one decimal place values, okay, when you're reporting, because there is always a mark allocated to reporting your values in one decimal place. So this is very important as while you report experiment. You have to measure temperatures or measure the volume on the volumetric flask. Ensure that you put the decimal places involved. Don't just write 26. If it is 26.2, clearly state there. If it's 28.5, always include the decimal places because there is a mark allocation for that. And when you are also fitting into the table, there is no need to include units. So don't include units into the table that you are fitting in the values into. So just write the values alone and ensure that the units are on the table. So if units are not included at the heading of the table, know that you can include that to ensure that the table is complete. So that's the fourth idea that is very important as you're writing paper 6. Ensure that when you're reporting your data, it's in a decimal place, the value is in a decimal place, and it's uniform. Okay, so you know how to read a thermometer, you know how to read a pipette, so you need to revise that. Okay, so tip number 5. Okay, so for tip number 5, you have to know how to use the table of ions. Okay, use the table of the ions. So when I talk about table of ions, we're talking about where you are given an unknown substance or you are given a known substance, and you have to use the table at the end of the paper to answer questions. So you have to learn how to make use of that table effectively. We're going to try and see how to make use of it during the course of this class for February, March 2024. Okay, so learn how to make use of the table for flame test, for tests for cations, anions, tests for gases. You have to know how to use the table. All right. And equally, you also have to know how to plot a graph. All right. Get the right scale is very important in paper 6. How to plot a graph and get the right scale. How to draw the curve. It's a graph that involves drawing a curve. You have to draw it well so that it looks well. And then how to extrapolate from the curve. So probably you have a curve, you should be able to extrapolate. Extrapolate means you are given a value to trace using your graph. So you should be able to trace it and show how the lines are, how you got the value. Don't just assume value. So trace it, use a pencil to trace it, and show how you got the data, because there is a mark allocation for this. So there's a mark allocated for this. So know how to trace, extrapolate data from a curve that you have plotted. That's another thing that is very important in paper 6. So that's the 6th point. Okay, so for the 7th point, you have to know how to plan an experiment. All right, and when planning an experiment, there are certain tips that you need to know, which is to mention the apparatus you would use for each step. Okay, what are the apparatus you use? You want to mention that you use either, depending on the experiment, you're using a Bunsen burner, or you're using a thermostatic water bath. Okay, or probably you want to measure the volume of liquids. You could tell us the kind of measuring, whether you're using a measuring cylinder, or you're using a burette, or you're using a pipette. So always take the apparatus you use in each case, okay? And then, if it's also good that if the mark allocation for planning an experiment is always 6 marks, okay, and I always encourage the learners or the students to have more than 6 points. So if you have more than 6 points, you put yourself in a safer position to get the 6 marks. So if you have, for instance, 6 marks are allocated for this question, and you have up to 8 points on how to plan the experiment. Okay, so if the mark guide could, favor you because you have 8 points that you've written, and 6 of them could be included in the 8. But if you have less than this, it will be difficult to get all the 6 marks because you are short of points and you never can tell where the points are coming from. But one area where the points comes from is the fact that you mentioned the apparatus. The other points goes to the fact, if it's an experiment, you mentioned the variables that you are controlling, your independent variable, the constant variable, or whatever. So you have to, when you mention that, you could also get marks for listing out variables you're trying to control or to measure. And it's also, you can also get marks for stating where every step, in case maybe you have to weigh, you have to state it. If you have to weigh a certain value, so the quantity you are weighing, it could also fetch you some mark. All right. So these are just the principles that could help you to get the 40 marks in paper 6. So these are the tips. So I'm just going to look through questions before we solve a past question. Let me look at the chat box for any question. So if you have any question, you could just type it and I'll read it and answer them as appropriate. So someone is asking, what is that P6QP solve tab? Can we do that? Okay, yeah, the P6QP solve tab is February, March 2024. It has been solved already by me, so I will just project it and see. Right, so only 5 people in class. Can you discuss Tuesday's paper instead? Okay, so I just wanted to give an introduction for the whole thing. So there's an avenue for private classes, but private classes is going to be paid. Okay, so paid classes for private. But this is just to help everyone generally in this paper. Okay, so for those that are not here, well, it's their, maybe they feel that they already know what to do. But I believe those that are here would learn 1 or 2 things from the tips that I've given. Okay, so let's now look at paper 6 that has been solved by me. So we could just run through it, and then I'll just be running through the questions. Okay. So one thing you need to know about paper 6 is you have to read information. A lot of information that you're giving, and those information would help you to effectively answer the questions. So don't just rush to give answers to them. Make sure you understand the question. Okay, for this question 1, you see that you were told that calcium carbonate is an insoluble solid, which is a very important information in solving the question. You were equally told that calcium carbonates can be made by adding excess calcium chloride to aqueous sodium carbonate. Now, this word excess is very important in this statement because it's going to help you as we go further. Now, you are given the equation of the reaction, which is given here, all right? And you can see that calcium chloride in excess was added to sodium carbonate, aqueous sodium carbonate, to give a calcium carbonate solid, which is insoluble, and then aqueous sodium chloride, which are the products. All right, so moving forward, you're given the two steps that were done. First was that excess calcium chloride was added in excess into the aqueous sodium carbonate. And then in step 2, it was stirred. All right, so stirring occurred. Now, the first question is saying, name the item of apparatus labeled A in figure 1.1. So you can see the apparatus labeled here, all right? So you have to label this. Now, some will say spatula. It's not spatula. Spatula is wrong because spatula is not used for stirring. What we basically use for stirring is the glass rod. So the glass rod is used for stirring and not the spatula. All right. So no, like I said, when I was introducing the tips for paper 6, you have to know the apparatus and their uses, the accurate uses of them. Okay. So you don't make use of the wrong apparatus for certain functions. All right. So that's for the first question. So we'll go ahead to the second one. Okay. So we go to the second question here. It says, suggest why the mixture is stirred in step 2. So why is stirring occurring in step 2? All right. Why do you have to stir? So we're stirring to ensure that the reactants are well mixed and to increase the rate of reaction. Okay, so stirring is simply you want the reactant to get mixed up. You know, you added excess of aqueous calcium chloride to aqueous sodium carbonate. So you want to ensure that all of the reactants are well mixed up to increase the rate of reaction. So that is why you stir. All right, that is why we stir, to ensure that everything is properly mixed and the rate of reaction is equally mixed. Let me see if there are any messages on the chat. Okay, so like you said, if you have any question while we're explaining, just type it into the chat box and I'll check and answer. Someone is asking which paper. This is February, March 2024. Okay, this is February, March 2024. We're solving it. All right. So we're solving this paper. Okay, so let's move to the next question there. It says, after step 2, student filters the mixture to remove the solid calcium carbonates. Okay, so the student filters the mixture to remove the solid calcium carbonate formed and collect the filtrates. All right, so you have to show a diagram labeling, draw a label diagram to show the apparatus used for the filtration process. So in filtration process, of course, you need a filter funnel, you need a filter paper, and you equally need where it is collected. So whatever you're filtering, where it is collected. And that is why, see the diagram, we have the filter funnel there. Okay, we have the filter paper, all right, and then we have a conical flask to collect whatever has been filtered. So whatever has been filtered is called the filtrate, right? So whatever is this liquid part of the whole thing, and then the residue are the solid parts that remains in the filter paper. So I label the filtrate, I label the residue, label the filter paper, label the filter funnel. So most times the math guide or math scheme might want to see the filter funnel labeled, filter paper, and probably the residue of the filtrate. So it's good that you draw everything and label it to be on the safer side. You draw everything that is involved in the process of filtration. That is the trick to this. So this is what is expected. All right, so moving forward. Now, the next question says that the solid calcium carbonate obtained by filtration is not pure. So identify one substance other than water, which is mixed with the calcium carbonate that makes it impure. So what makes the calcium carbonate impure has to do with, look at the reaction. So if you look at the reaction, you get an idea of what is making this calcium carbonate impure. So looking at the products, you see that calcium carbonate is one of the products, but equally there is aqueous sodium chloride. So this could make this product impure. So this is one of the things that is making this impure, okay, because you have some quantity of aqueous sodium chloride in this. So that is one. So this is number one. And then secondly, remember that the calcium chloride was added in excess. So since it was added in excess, you're still going to have some quantity of it in here. Okay, it could be very minute, but you could have some quantity which is acting as an impurity. So either you write aqueous sodium chloride as one of the answers there, or you write this because this was added in excess, so it's still kind of present. If it's not properly filtered, or even when properly filtered, you should have some quantity in the calcium carbonate, which is a product. So that is why in our answer there we have that. Okay, so in our answer we have calcium chloride or sodium chloride as the answer to that. Now, the second question says, describe how the substance you have identified in DI, how it can be removed from the calcium carbonate. So just like when you're preparing insoluble salt, after you have filtered, the next step is to what? To wash the residue with distilled water. So by washing the residue, which is calcium carbonate, we can remove the impurities. Okay, so the next question, describe a test the student can do on the filtrate obtained in C to show that the calcium chloride used is in excess. Give the result the student obtains if the calcium chloride is in excess. Okay, so you want to test if the calcium chloride that is obtained is still in excess. Okay, you want to obtain if from the filtrate, if the to show that the calcium chloride used is still in excess. So you could do an experiment, consult the table at the end of the experiment to see what you can test for. Either you're testing for calcium or you're testing for the chloride ion. Okay, so but here we are testing for the presence of calcium in the filtrate. So we just had aqueous sodium hydroxide, and if you have a white precipitate, that should still tell you that there's some calcium present. Well, you can test for the chloride part of the whole thing. And you know the test for the chloride is to use dilute nitric acid and silver nitrate. So you could check your table. So go all the way down to the end of the experiment. All right. You see all the way down. Yes, you can see how to test for the chloride. You can test for the chloride as well there. So you had dilute nitric acid and then aqueous silver nitrate. If you have a white precipitate, that should still tell you that the chloride part is there, which also proves that the calcium chloride is in excess. So that is how to do that. I believe it's clear, but if it's not clear, you could simply ask a question using the chat box. All right. So moving forward to the next question. All right, so moving forward to the next one. The next question says, okay, so we are done with question one. So you can see that question one is simply testing your knowledge of salt preparation, all right, the basic principles of salt preparation and, filtering and the like. So it's as easy as that. So in the one you want to write on Tuesday, it could be on paper chromatography as the first question. So the major thing is understand the principles involved and you'll be able to answer it. Okay, so we go to question two now. All right, so for question two, I'm going to be really fast with question two because I intend to have another class by 5 o'clock. All right, so a student investigate the reaction between aqueous sodium carbonate, all right, and two different solutions. All right, so if you look at details of the experiment are underlined here. So in the first experiment one, what we are simply using is dilute hydrochloric acid A and 25 centimeter cube of the sodium carbonate was used. So this is going to be in the burette, while this is going to be in the conical flask. So you are titrating using methyl orange as the indicator for experiment one. Now, if we go all the way to see what happened in experiment two, you still use the same dilute hydrochloric acid in the burette. You use the same quantity of aqueous sodium carbonate, but this time you change the indicator. Instead of methyl orange now, you're using thymophthalate. And then, of course, the white tile is used for the titration process. Okay, we're going to see why the white tile is used anyway. And then we have the third experiment. You change the acid this time. You're not using dilute hydrochloric acid A again. You're now using dilute hydrochloric acid B. So we can see that for the first two experiments, you are using dilute hydrochloric acid A, but there is a change of indicator. But for experiment 3, you are using dilute hydrochloric acid B, and you use the methyl orange as the indicator. So that will help you answer this. So for step 1, experiment 1, the indicator is methyl orange. For experiment 2, the indicator is timophthalene. Let's see if it's going to affect the results. We're going to see that. Okay, so let's move to the question part of the whole thing. Okay, so you are given different burette readings and you're asked to pick it up. Okay, so for experiment 1, you're going to pick out initial reading and final reading. So if you look at experiment 1 now, you see that this is 0.5678. So this is 0.8 and this is 26.2. So we'll go all the way there to see how we have reported the reading. So we can see all the readings have been very well reported. And you can see that what I said earlier materializes here. All the values are in 1 decimal places, which is one of the things that will get you marked, okay? Making sure that your data are reported in the same decimal place. So I've reported this way. So that will now help me to solve the question, okay? So I've completed the table. Remember, for experiment 1, we use methyl orange. For experiment 2, we use timophthalene. And for experiment 3, we change the acid and we use methyl orange again as the indicator. So that's how to complete the table. So when we get initial and final reading, all you need to do is to subtract. So 26.2 minus 0.8 gives you 25.4. And you go on like that. Okay, so subtract 12.9 from 0.2 and the 39.1 from this, and then you get the volume of hydrochloric acid that you added. Now remember, the process of titration, the acid is in the burette. So this is the acid in the burette. There is a conical flask, all right? And in the conical flask, you have the alkali and you have the indicator. So you're titrating, you're adding droplets of the acid into this conical flask until there is a color change to the neutral. When there's a color change to the neutral, you stop adding the acid and you check the volume of acid that you have added. So that is what this simply represents here. Okay, so let's see what are the subsequent questions that follow. So the first question now says, which solution of dilute hydrochloric acid, A or B, is more concentrated? So for us to know the one that is more concentrated, remember, this is A and this is B. So this value and these values are for A, and why these values are for B. But the one we can compare directly is the one we use the same indicator for. So we use methyl orange for experiment 1, and we use methyl orange for experiment 2. Though the acids are different, but we are using the same indicator. So comparing them, you see this one has 25.4 and this one has 38.1. So the answer to this will be the most concentrated is the one with lesser volume. That is, because it is concentrated, it needed lesser volume to reach the endpoint. So that is why we said A is the most concentrated. So if you have a question like this, look for the lesser value. The lesser value simply means it is more concentrated. That is why you don't have to add enough of it to achieve the neutral or the endpoint. So we said A is the most concentrated. We said solution A has a lesser volume, which makes it more concentrated. So when something is more concentrated, you don't have to add too much of it because it is concentrated and it will give you the result as soon as possible. And the next question says, did you use how many times more concentrated this solution of the dilute hydrochloric acid is than the other solution of dilute hydrochloric acid? So using the information we got in BI, we have to tell compare now, how many times is solution A more concentrated than solution B? So all you need to do is to go back to their volumes and divide. So if we divide, remember we are comparing 38.1 and 25.4. So all you just need to do is to do 38.1 divided by 25.4, and you observe that you're going to have 1.5. So that means solution A is 1.5 times more concentrated than hydrochloric acid B. So hydrochloric acid A, which is solution A, is 1.5 times more concentrated than hydrochloric acid B. All you had to do was to just divide. Some students will make the mistake of subtracting. No, you don't have to subtract. Just divide their values and you know the number of times in which one is more concentrated than the other. So moving forward now, the next question says compare, okay, it says compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A used in experiment 2. So we're going to go and compare now. So let's go to the table. So we have to compare this and this. So you see that experiment 1 has a larger volume than experiment 2. Okay, so since experiment 1 has a larger volume than experiment 2, and that question is for 2 marks, you have to state 2 reasonable points. So there is more acid is used in experiment 1 than in experiment 2. Also, experiment 1 volume is 2 times that of experiment 2. So for us to know this, all we need to do is to divide the value of experiment 1 and experiment 2 to know the number of times. So because it's 2 marks, the first mark is where you state which one is more. So we said more acid is used in experiment 1 and experiment 2. And then the second reason is that in terms of comparison, because we have to compare, we see that the volume of experiment 1 is 2 times that of experiment 2. All right, so that is for that question, just by looking at the table. Okay, so the next one says deduce the volume of dilute hydrochloric acid B required to reach the endpoint if experiment 3 is repeated using thymophthalate instead of methyl orange. Now we used methyl orange, we used thymophthalate for experiment 2, but we used methyl orange for experiment 3. So the question is, what if we didn't use methyl orange for experiment 3? What if we had used thymophthalate? I remember that we just compared experiment 1 and experiment 2. And we said experiment 1 volume is 2 times that of experiment 2. Experiment 1 volume, experiment 1 experiment, we use methyl orange. Experiment 2 experiment, we use what? Thymophthalate. So since experiment 1 volume is 2 times that of experiment 2, for us to get what experiment 3 will be when we are using methyl orange and we want to switch to thymophthalate, it's going to be the volume of experiment 3 divided by 2. Okay, it's going to be the volume of experiment 3 divided by 2, and that is 19.05 centimeter cube. So that is that for that question. Okay, so next one says at the start of the experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid. So identify the substance removed from the burette when it is rinsed with distilled water at the start of experiment 3. So before you started experiment 3, you have done experiment 2. And for experiment 2, from the details of the experiment, you see that it is acid A that was used in experiment 1 and 2. So you are rinsing the burette with water to remove the solution of acid A. Because for experiment 1 and 2, it was acid A that was used. So in experiment 3, we are switching to acid B. So the essence of rinsing is to remove solutions of acid A. Next one says, describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid B after it had been rinsed with water. Now, after you've rinsed the burette with water and you did not rinse the burette again with dilute hydrochloric acid, some droplet of water will still remain in the burette. And when there is some droplet of water still remaining in the burette, by the time you add hydrochloric acid B, the water droplets in the burette would mix with dilute hydrochloric acid B to bring down the concentration. Remember that to reduce the concentration of an acid, all we needed to do is to add water. So it's important that you rinse the burette again with the acid you want to use so that you remove any droplet of water left over after first rinsing. So the answer here remains that the concentration of the acid decreases and therefore more volume of acid B will be required because you have reduced the concentration. You have to keep on adding a lot of volumes of B before you can get the end point. That is why you need to rinse again with the acid you intend to use to titrate. The next one says, explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. Now, if you rinse, after you rinse the conical flask with water, do not rinse with aqueous sodium carbonate because by the time you rinse it with aqueous sodium carbonate, some of the quantity of sodium carbonate will remain in the flask as droplets. And this will increase the volume of sodium carbonate to be used. In the experiment, you're expected to use 25 centimeter cube of sodium carbonate. So if you have measured 25 centimeter cube in a measuring cylinder, and then you now rinse the conical flask with some quantity of sodium carbonate. Some droplets of sodium carbonate will remain in the conical flask. And by the time you add 25 centimeter cube of it again into the conical flask, it will be more than 25. And that will affect the titer value because you have increased the volume of sodium carbonate to be used. So it doesn't make the experiment accurate enough. The next one says, explain why a white tile is used during the titration. Of course, you know why white tiles are used during titration is to ensure that you can easily observe the color change or the endpoint. So the white tile gives you a clearer view of the color change expected. All right, the next question says, describe the effect on the result of warming the aqueous sodium carbonate used in experiment 1 before carrying out the titration. Now, when this question is asked, a lot of students will say, oh, when you warm, the rate of reaction is increased. Therefore, the titration process is shortened, or maybe you get the titer value easily. But no, titration is not dependent on the temperature, but it's rather dependent on concentration. So when you warm the aqueous sodium carbonate before you perform the titration, there'll be no effect on the titration. Okay, because titration is dependent on concentration. And when you warm, it doesn't affect the concentration. Yes, it increases the rate of reaction, true, but it doesn't affect the value, the amount of volume you need to add to obtain endpoint. That's the point you need to note. Titration is dependent on concentration and not the temperature. So that is for that. Okay, so just hasten up a bit. This is where you test for substances. You are given solid C and D, and you are told that solid C contains ammonium iodide. So it's likely, because you are given the name of the compound here, it is possible and very possible that you'll be testing for either ammonium or you'll be testing for the iodide. Okay, this is where you get to make use of the table. You don't have to cram any value, so you make use of the table. So when you make use of the table, it says the first one, you add dilute nitric acid followed by a few drops of aqueous barium nitrate. So this is not a test for either ammonium or iodide. So if you check your table, just consult the table. I'm just going to be fast with this because it's almost time. So you just check your table, okay? You can see that when you add nitric acid and barium nitrate, you are testing for sulfates, not for ammonium and not for iodide. So that's why in that particular part of the question, we said no change or no effect, because it's the wrong test for any of the ions that are there. So no change. And then the second part says, okay. All right, the second part says, so the second portion of solution C, the student adds about 1 centimeter cube of nitric acid followed by a few drops of aqueous silver nitrate. So when you add few drops of this, you know you are testing for the iodide, and that is why it gives a yellow precipitate. So this is the correct test for the iodide part of the compound. So that is that. Okay, so I'm just going to skip this part. Of course, this could be sent in to help you revise. I could send it to Ajiro to help you revise. But I want to go to planning an experiment. Okay, I want to go to planning an experiment so that I could round up this class. But if you need extra or personal classes, you could meet with Ajiro and you could organize it. This is just a free class to encourage you and to help you. So this is where I'm going to end this class. I'm going to talk about briefly on how to plan an experiment. Okay, so it says when excess dilute sulfuric acid is added to solid zinc, hydrogen gas, and aqueous zinc sulfate are made. Okay, so plan an experiment to show that copper is a catalyst. This is very important. You want an experiment to show that copper is a catalyst, and your plan should include the result of the experiment to show that copper is a catalyst for this reaction. So it means you have two reactions that you're going to be performing, the one with copper as a catalyst and the one without copper as a catalyst. All right? So your catalyst is given, the reactants are given. So the first thing I always encourage students to do is to list out all the apparatus you'll be needing. Of course, you have to weigh the zinc, or you equally have to weigh the catalyst, because you have to weigh, because when you're testing a catalyst, remember the definition of a catalyst. It speeds up the rate of reaction and it remains chemically unchanged. That means the mass of the catalyst at the beginning must be the same as the mass of the catalyst at the end. So that means you need to weigh your catalyst. Of course, you need to measure the volume of the acid. And you have to use the same concentration of the acid, and then you need a water bath if you choose to, heat, as the case may be. All right, so variables you need to control. You need to control, use the same mass for the two experiments. The same volume of acid must be used. You have to maintain the same temperature, and you have to use the same time to see how much gas is produced, and then you can now, write what is expected. Okay, so and at the end of the experiment, you need to weigh the catalyst again, weigh before the experiment, the mixture, wash the catalyst with distilled water, dry it, and reweigh. When the weight of the catalyst and the weight of the catalyst before the reaction and the weight after the reaction are the same, then you can truly say that the copper is a good catalyst. And then apart from that, you also have to look at the rate of reaction, look at how much gas is produced without the catalyst and with the catalyst. That's also is also a way to judge. So it's for 6 marks, but I told you it's better you list out about 8 points, combine all of this information. When you list out about 8 points, you are sure that you find yourself within the mark scale.